programming engineers. Welcome back once more to this drives course. And today I'm going to be showing you the plate or data plate and what information is really necessary to enter in a drive without the need of having to input a specific brand. So I'm going to tell you which values are absolutely necessary and which ones are obligatory to program your drive. Now, for all this, let's move forward then. We had previously checked our induction motor as their different applications work. So at the moment of having my induction motor, at the moment that I'd like to control it, I need to have a drive which supports the same potency and the same voltage. Okay? For what, you ask? For my motor. So further down, I'm going to tell you how a drive works. But at the moment of this data for the motor data, you need the voltage and the kilowatts or watts or its potency. Okay? Now, what are the motor's data plate? When we buy a new one, they're going to give us the motor as such together with its data plate. So let's go back a bit right here. The data plate is this one. It is basically the information, the general information and important information for that motor. These are very important, and this is on the motor, whether you want it to or not. This needs to be put on the Bornus plate. Remember, this one has the terminals where I should connect my voltage. Now, on the lid, when we open this, later on we're going to, I'm going to open this when we're right on the practice, but right now I want to tell you about it. It has its screws, and we need to remove them. So we just turn it, and we should have the data plate. If they're not here, they're not going to be anywhere else, unless the new company wants to be completely different and wants to write them down in a different place. But ideally is to leave it out in the open. Now, what happens with the old and obsolete motors? Let's call them that. The ones that are older than 30 years. Now, it's not the same. It's true, but they're still working. Now, what would happen if we don't see the plate number and the drive is damaged? The first thing we should do is we need to check the drive to see what model it was. So we could check how much potency a motor can take, or whatever motor you'd like to handle. If for whatever reason it doesn't have a drive and you want to add a new device for frequency variator for a new drive, then in this case you need to get the data plate for that old motor. But if it's very old and if you can't see its data, then in this case it's going to be a little bit more complicated to know its characteristics. The data plate is good to identify its general characteristics, or in a quicker way to get a drive and check its potency to see if it's compatible to control this motor. Okay? Now, if they don't exist, its potency, in this case, we can calculate it. Remember, guys, we should always have the formula for potency or voltage or current. And these are the easiest ones. So if we wish to calculate the potency, all we have to do is take our multimeter, connect it to the terminals, and get the tri-phased potency. If it's 220, and let's suppose then that now then I would have to take my multimeter with a hook multimeter, and I would have to measure the motor feed. So whatever turns from this, whatever happens from this, if it's 4 amps, for example, then how much is it going to leave us? If it's 220 times 4, now why are we multiplying this directly? Because of the potency formula, which is voltage times current. Okay, it's nothing new. We already know this. We should know this. Okay, now this is the way that we have the potency, which is a pretty considerate data and very important as well. So we can enter it in my new drive. This in case we don't see the data plate. And if we can't do with either one of those, we should be able to measure the speed directly from the shaft or the application, and we run a conversion calculation. But this is what the data plate is for. How long or how much would we take? How long would it take to measure? I mean, we can get this for voltage and amps. The problem is that this takes a little bit too long. So we see here the characteristics that we need. Now, careful though. We should enter, this is whether you'd like to or not. The first thing that they teach us, and what I'm showing you guys in this drive course, is to enter the data plate data. Now, you guys are going to say, well, you need to, some other engineers are going to tell you, well, you need to enter the most important data, and other engineers are going to say, no, you need to enter as much data as possible. That way you can make the motor more efficient. So all I can tell you is, based on experience, is enter not the most amount possible, but the most necessary ones. Now, which ones are the most necessary ones? As a general data, we have here a data plate for Siemens. And we have, first off, the manufacturer. In this case, Siemens. And then we have type, size, and construction, the way it was built. Some of them even give us the weight. We have a current class, alternate or continuous. Serial number for the machine. We also have it here. We have the stator winding. If it is delta or starred, and the nominal tension for frequency, etc., etc., etc. So all you need to do is enter all necessary data. Now, what do I mean by enter? The data plate for our motor, we need to input, or we need to enter them to our drive. Through what, you may ask? Through parameters, configuration, etc. Now, I'm going to go back here. So this is our drive, yeah? And now I'm going to show you this a little bit more in detail with our photograph. We have our screen or our display, and here we're going to get the option to enter our parameters for our drive. So the parameters, they're pretty important because thanks to the information that we have here, or that we enter here to our drive, it's going to be closer to run the movements that are adequate internally, and that way we can command those same movements and those same variables to my application, which in this case is going to be my induction motor. Now, look at it this way. I had previously said this in different courses, but it's the same thing here. If I wish to adjust correctly and adequately with a lot of quality a newly bought guitar, what would happen if I want to tune this? If I want to tune it correctly, it's not going to be the same thing. A well-tuned guitar to a completely new melody for a new guitar, from a new guitar. So there's always going to be, and there's going to be the need to adjust our tuning. Okay, we always have a chance to do some fine tuning. Okay, now here's something very similar, guys. We bought our drive, okay, but there's a range for us to control our motor, our induction motor. So in the end, all we want to do is control our motor. Now let's suppose that I buy a 5 HP drive, 5 horsepower drive. That same drive is the only one that I have available. I don't have any other one in stock. But I really want to control a 2 horsepower motor. Okay? Now the drive may handle any type of motor, just as long as it is below or under its potency. Okay? So the potency is 5 horsepower, and the max potency, which is the max potency that the drive can handle. But if I want more, can it be done? Yes, it can, and they're going to have the same optimization. So therefore, our 5 horsepower drive, is it going to have the same? No, it's not. We need to adjust its values. Okay? We need to adjust the drive value so that we can optimize and make it more efficient for our variables, which in this case is going to be very useful, our currency. Because however bigger the potency, or however larger the potency, we're going to increase the current. Okay? So this is direct formula. So it's not the same current that I'm going to use with 5 horsepower than the one that I'm going to consume with 2 horsepowers. So if I leave it as such, it may work. However, I'm going to have more problems with efficiency, and even if we don't notice, it's going to cost the company money. Now, people are paying us so that we can make processes more efficient. Okay, let's not forget that. But if we can adjust the values for gains or currency or potency within our drives, it's going to be much better. Okay, so that's lesson number 1. But for that, we need to enter our data plate. We need to say, well, these are my values, and you need to run your internal algorithms so that you can be a little bit more efficient. Now, that's what this is for. This is what we have our data plate. Okay? Now, why am I saying that these are the data, or some of the general data? And why we shouldn't get overconfident in getting all the data plate for our motor. Now, probably it is going to be a little bit more efficient. However, based on my experience, I've noticed that it doesn't change as much. The really important values in which the drive notices this and says, you know what, this is the most important thing, so that this is what you need to change for my efficiency. This is the really important data that we need to enter. Okay, voltage, nominal currency, potency, and RPMs. That's it. RPM is speed. That's always going to be in the data plate. Now, by any chance, if you have the data plate, and for the polar numbers, enter them. If not, don't worry, guys. They're going to be set as default. And the optional data is the potency factor. Okay? Now, in the RPM part, all you need to do is you need to ensure that they are, well, once we're talking about speed, you also need to ensure that they are going to be the frequency, the adequate frequency that you need. Now, generally, for example, here in Mexico, all the frequency is going to be in 60 hertz, okay? However, maybe in Europe, the max frequency that is going to be used now is going to be 120 hertz. Now, it is impossible that here in Mexico they use 60 hertz commercially within the industry. Okay, it's not possible because the company, the Mexico company, is using the max frequency for 60 hertz, and this is standard. So every country is different. That's why you always need to ensure that the frequency be the correct one in your country, according to your country. That's the only extra thing that we have here, but we're going to leave this together with our RPMs, which is our speed. Now, why is voltage important? Because, for example, here we use delta and star, and depending on the connection that we have, that we need to use, is going to be the voltage that we're going to have to induct or connect in our borders for our border terminal. Okay? So therefore, if I have my delta connection, then I would need to use 400 volt connection. And I'd need to enter that data to my drive. So nominal current, depending on the type of connection that we have on our borders. If this is delta connection, it's going to be 32.5 amps. If it's star connection, then that's 18.8 amps. Now, notice this, guys. You're also going to notice on company costs or budget. Okay? So if we use higher voltage, then in this case, we're going to decrease our amps. Okay? Excellent then. Now, check this out, guys. We have our potency here. What's the unit that we're going to be using? This is watts. So this is 18.5 kilowatts or 18,500 watts. Now, RPMs, let's look for them here. Now, this same plate is the one that we had at the beginning. So I'd like us to run some drills based on the important data that you guys are going to have to enter in your drive. So RPM, let's look for these. Here we go. Let's suppose that these are 2,940 RPMs, which are revolutions. Okay. Now I should enter this data in my parameter. Now we're not looking into parameters because it's still a long way to go before we go into parameters. Okay, so don't get, you need to be very patient, guys. We're just getting started, okay? But it's still pretty important. Okay, but it is absolutely necessary. If you're going to learn something, learn these values for your data plate. And finally, the optional part, the potency part. If you guys don't have any potency part, don't go in. Okay, this is the only thing, the only additional thing that I can suggest that you enter. If you can't add this, then don't worry about it. Okay? But you'll notice here that this data is for 50 hertz and this one is for 60 hertz. So all we need to do is we need to analyze which hertz are the ones that we're going to need. Okay? So we shouldn't listen to this, and we should listen to these other data. Okay, depending on the frequency that you guys have in your country. Okay? Now, motor data plate. We're going to run a drill all together, and we're going to enter our data plate that we have here. So I'm going to leave this to you for a couple of seconds. You're going to pause the video. pause the video, and literally enter in a notepad, enter the data. For example, I'm going to do this with you guys. So motor 1, these are different brands, you notice? We have Siemens, we have Earl Drive, we have an Alren, and we can practice all together. So what do we need? Voltage. Okay. What voltage is this? 220, which is the ones that we need. So all you're going to have to do is enter the data in a notepad so that we can later on practice with our drive. Okay? Now this is 50 hertz, and this is the max amount. So there's nothing I can do. Now what else? Voltage, 220, amps, or current. .64 amps. Now what's next? Potency, 0.37 kilowatts. Now what's next here? RPMs. Okay. So 2800. And finally, the potency factor, which is 0.95. Okay? Now, if you notice, this company for Alren were pretty smart. And what they said was, all I'm going to do is I'm going to enter the necessary data in the data plate. So that's why I'm saying don't take as long in entering all this data. Just enter whatever is essential. Okay? For example, you should already follow this data plate with these other data plates, with this other data plate, and these other data plates. Now, please practice this, guys. Now, add motor number 2. If you want to copy this and paste to Excel, data sheet, you can do that. Now, let's go to 230. This is delta. And you can start practicing how to get all this information, okay? Very well. So let's pause and we'll meet again in our next topic. All right, guys. You should have already entered the data for each motor plate. Now, this is only as an example for all of us, and the goal is that you guys should be able to tell apart, no matter what the brand is for the induction motor or the AC motor, so that you guys can lose or stop being afraid of this. And thanks to this course, you can be able to basically configure whatever drive you're using, no matter what the motor is that you're using. So it shouldn't matter, the brand shouldn't matter. All you need to do is to be able to identify the correct data that you guys are going to need to be able to configure its variator. Now, this data, I'd like you guys to add it in your comments. Whether you basically did it and copy paste, so that we can tell between all of us who are studying this on any problem that we have, or maybe reaffirm that if there's something that was wrong with any of the data in these data plates. Okay, this is basically for us to collaborate together, because we are a community. And you guys are going to be able to notice, and you're going to be able to tell in case you have any errors with some entered data. Now, you guys are going to say, you know what, Rodrigo? What are these data going to be good for? Well, as I had previously said, for this data functioning, maybe you're going to have some questions on how to enter into your drives. And this is what we're really interested in. Okay? So don't worry, guys. We need you guys to correctly affirm this issue in your motor data plate. Because later on, we're going to run many different drills with many different drives, and we're going to enter the data plates in the different variators, which is what is really important to check the voltage, to check the current, all these potencies for different drives, and they're basically going to be the same thing. Okay? Now, once we finish this topic, let's move on to our next one. Thank you very much for your time, guys, and I'll see you on our next video. Big hug, guys.